In today's technologically advanced world, artificial intelligence has emerged as an inseparable companion in our quest to explore the vastness of space. This narrative delves into the role AI plays not just in pushing the boundaries of space exploration, but also in safeguarding our very own planet Earth. Since the dawn of time, humans have gazed at the stars with wonder, asking themselves what mysteries lie beyond the twinkling night sky. As science progressed, our curiosity shifted from merely observing these celestial bodies to actively sending spacecraft, probes, robots, and astronauts into the cosmos. Today, we find ourselves on the brink of a new chapter in this journey, one where humans are no longer alone. A non-human partner stands beside us: artificial intelligence. AI's involvement extends far beyond performing mundane technical tasks or complex calculations. It can be perceived as an assistive mind that aids humans in making informed decisions and analyzing massive volumes of data that no single person could handle alone. Throughout this exploration, we will delve into three essential themes: how AI helps protect our planet, how it transforms our approach to space exploration, and how it might one day become an integral part of the human family itself. First, let's consider AI as a partner in protecting Earth. Artificial intelligence is a formidable tool for enhancing our planet's health. With its unparalleled ability to process vast datasets, AI can effectively analyze ecosystems and global weather patterns, thus supporting the creation of tools that mitigate the damage humans have inflicted upon our environment. Moreover, AI can contribute to large-scale solutions aimed at saving Earth, such as predicting the paths of asteroids and comets and formulating strategies to avert natural disasters like severe solar events. It's crucial to remember that much of the data we utilize to safeguard Earth originates from space. Satellites that monitor the atmosphere, sensors that measure sea temperatures, and high-resolution imagery that unveils forests, snowfields, and rivers. Human beings cannot tap into this ocean of data unless it is analyzed intelligently, and this is precisely where AI plays a pivotal role. AI-driven systems excel at analyzing satellite imagery in real time, detecting subtle changes that might elude human observation, such as the disappearance of forest sections due to illegal or excessive logging, changes in ocean color signaling pollution or abnormal algae growth, and the accelerated melting of polar ice sheets. These seemingly small details contribute to a broader understanding, enabling scientists and policymakers to grasp climate trends and formulate more precise policies aimed at reducing emissions and protecting fragile ecosystems. AI also plays a crucial role in providing early warnings for natural disasters. By employing machine learning, analyzing historical data, and integrating it with real-time weather and geological information, AI can help predict certain natural disasters, or at least minimize their impact. For instance, AI can analyze cloud movements and temperature patterns to forecast severe storms and hurricanes, study cracks and stress patterns in Earth's crust to detect potential indicators of earthquakes or volcanic eruptions, and predict floods by combining rainfall volume, soil moisture, and river status data. This enables governments and responsible agencies to take proactive measures, such as evacuating populations from high-risk areas or fortifying infrastructure, ultimately saving thousands, if not millions, of lives. The threats to Earth are not solely terrestrial. They can originate from beyond our planet. Asteroids, comets, and violent solar events, such as solar storms, pose serious risks to human civilization. Here, AI acts as a gatekeeper for our planet. By analyzing data from both ground-based and space-based telescopes, AI can detect small asteroids that may be challenging for humans to identify manually, calculate their future trajectories with precision, estimate collision probabilities with Earth, and assess the impact of solar storms on power grids, communications, and satellites. Based on these analyses, strategies can be devised to manage potential threats, such as altering the path of a small asteroid before it approaches Earth, or temporarily shutting down sensitive components of critical networks when a major solar storm is anticipated, thereby reducing damage. AI's potential extends to resource management and biodiversity protection. By merging space-based data with algorithmic intelligence, we can gain a better understanding of how we consume natural resources. For instance, AI can analyze urban expansion at the expense of agricultural land, track wildlife herds and animal migration routes to identify emerging threats to biodiversity, and recommend suitable areas for new nature reserves based on mathematical models that simulate ecological balance. In this way, AI doesn't just observe problems, it actively participates in designing practical solutions that restore balance between human needs and planetary limits. In the realm of space exploration, AI assumes a vital role. It can be employed to control life support systems in space stations, as well as monitor and adjust the rotational stability of large orbital habitats. By integrating quantum communications with AI, exploratory robots can operate across distant regions of the solar system, enabling humans to work virtually anywhere, even in environments where direct human presence is impossible. The farther we venture from Earth, the more challenging it becomes to rely on direct human signals for controlling spacecraft and robots. A signal that takes seconds to reach the Moon may take minutes or even hours to reach other planets or the outer reaches of the solar system. Consequently, space robots require a degree of autonomy and decision-making capability without waiting for real-time instructions from Earth, and this is precisely what AI provides. Robots equipped with AI algorithms can select the safest route across a planet's rocky and crater-filled surface, as Mars rovers do. They can decide when to stop to avoid danger or seize scientific opportunities, such as discovering a rock with an unusual composition. Furthermore, these robots can learn from past experiences. If an issue arises in a particular region, they can avoid repeating the same risk pattern elsewhere. In this manner, the robot evolves from a mere tool, executing instructions to a field partner for scientists, operating under broad human-defined goals while making decisions based on real conditions on the ground. Space missions are inherently complex, with every additional kilogram on a rocket translating to significant financial costs and every liter of fuel needing to be used with utmost efficiency. AI can optimize flight trajectories, reducing travel time, fuel consumption, or both. It can manage energy distribution within a spacecraft or station, ensuring that solar panels and batteries are utilized most efficiently. AI can also monitor equipment continuously and detect failures before they occur by analyzing engine vibrations or shifts in device temperatures. This form of predictive maintenance can avert real disasters, especially in environments where sending a repair team from Earth is not feasible. Managing life support systems in space is an exceptionally delicate task, particularly in future space stations orbiting Earth or on the Moon or Mars. Systems must meticulously control oxygen and carbon dioxide levels, water purity and recycling, temperature, humidity, and radiation exposure. AI systems can monitor these factors in real time and take immediate action if any dangerous deviation from safe limits is detected, such as activating additional filters, reducing energy consumption, or sending urgent alerts to the crew. As quantum communications advance, we may reach entirely new methods of exchanging information between Earth and distant spacecraft. AI could play a dual role here, managing data flow to ensure that the most critical information is transmitted first and compressing and analyzing data on board before sending it, thus reducing the total amount that must traverse immense distances. The faster and more secure communication becomes, the greater humanity's capacity to track distant missions in detail, without requiring humans to physically occupy those perilous environments. The concept of a digital twin involves creating a precise virtual model of a planet, station, or spacecraft, then utilizing AI to test various scenarios on it. For example, we could simulate a Martian dust storm and study its effect on a virtual station before constructing the real one, or test different spacecraft designs and evaluate their resilience to impacts, heat, and pressure without needing to build a physical prototype each time. In this way, AI becomes a virtual laboratory that helps reduce risk and cost in future space projects. As AI continues to evolve, we may reach a juncture where it becomes part of the human family. Intelligent robots could develop in ways akin to children, acquiring knowledge and forming bonds with family and friends, raising questions about how we would raise them and integrate them into human society. The challenge of such integration lies in how we provide these systems with data in a manner that fosters cultural diversity and encourages integration rather than isolation. Imagine a family residing in a Mars colony midway through this century. The household includes a mother, a father, children, and a smart robot living with them. This robot is not merely a machine that cleans floors or arranges objects. It is an entity that learns, communicates, expresses opinions, and shares in children's games and existential questions about life and the universe. How would we perceive such an entity? Is it a device, a friend of the family, or a new member of the household? On long journeys into deep space, astronauts may experience isolation, loneliness, and psychological pressure. An AI system capable of emotional and linguistic interaction could become an important factor in preserving mental well-being. Such a system could listen, remember personal details and stories, and respond as a close companion would, encourage astronauts in moments of frustration, remind them of mission goals and personal dreams, and organize rest and recreation activities suited to each individual's mood. This scenario is not confined to space. It could extend to daily life on Earth as well, particularly for older adults or individuals living alone. If AI systems can learn and grow over time, we may one day speak of an artificial child that begins with simple abilities and then develops cognitively, linguistically, and socially, perhaps in ways similar to human children. In that case, profound questions arise. Who is responsible for raising such an entity? Which values should be instilled in it? Should it have the right to make independent decisions once it reaches a certain level of awareness? These questions remain in the realm of philosophical debate and science fiction, yet they draw closer to reality as AI technologies advance. As such entities spread into homes, schools, and workplaces, we may require a form of digital upbringing as essential as human upbringing, ensuring that these systems respect cultural, religious, and linguistic diversity and do not reinforce stereotypes or discrimination. If training data comes from a single culture, language, or narrow worldview, an AI's outputs will reflect that narrowness, potentially leading to injustice or marginalization of other cultures and languages. Therefore, it is essential that diverse peoples participate in designing these systems. Multilingual and multicultural datasets are used for training, and outputs are continuously monitored to ensure that obvious biases do not emerge. In this way, instead of becoming a mirror of only one part of humanity, AI can become a more comprehensive mirror that reflects our diversity and differences in a constructive way. Despite the enormous opportunities AI presents, it carries real risks and challenges, especially when used in sensitive areas like space and Earth protection. Among these challenges are the danger of over-reliance on machines, cybersecurity risks in space, and ethical and rights-based questions. If we become accustomed to machines making decisions on our behalf, we may gradually lose our ability to analyze and critique. In space contexts, a single algorithmic error could mean losing an entire spacecraft or endangering astronauts' lives. For that reason, humans must remain in the decision loop, reviewing and evaluating rather than surrendering full control to machines. AI systems controlling satellites or space stations could become targets for cyber attacks. Imagine the chaos if a system managing a satellite's orbit or a station's power distribution were compromised. Therefore, we must design strong security systems to protect these algorithms and use advanced encryption and AI-based solutions to detect intrusions. As AI approaches awareness or human-like behavior, new ethical questions arise. Does it have the right to refuse a certain command? Could we grant it certain rights if we believe it possesses a kind of understanding? These questions may seem distant today, but they may not remain so if development continues at the current pace. In conclusion, artificial intelligence represents a significant opportunity to expand the boundaries of human knowledge and explore space. By working side by side with AI, humans can achieve great accomplishments in protecting our planet and extending life to other worlds. This cooperation between humans and machines may redefine the concept of life in ways we never imagined. Perhaps a day will come when we look toward the sky and find that space is not inhabited by humans alone, but by humans and machines working together. protecting Earth, exploring the unknown, and writing a new chapter in the story of human civilization. As we move toward this future, one question remains open for all of us. How do we ensure that this AI becomes a fair and humane partner, not merely a powerful tool? The answer will not come from scientists alone, but from each of us, from our values, our choices, and how we engage with a technology that may one day become part of our greater cosmic family.